Okay, so as I mentioned in my last blog, I was getting moulds made up to make the plastic pistons that fit inside the pipe and pump. Unfortunately, the local ministry, with their very limited tools, couldn't make it to anywhere near my original design. Tried to get another engineering firm in town to modify the moulds to try and make them work, but they couldn't do it either. But they didn't charge me for trying. It was very nice of them. So instead, it improvised. Got these plastic backing packaging you can see here from these sprung roof nails, washers. You can see here. Cut them up, put them on a bolt, put them in a drill. Got a sharp knife and tried to cut them down so that they would fit snugly inside the pipe. Very rough and ready technique, but it worked. But yeah, definitely not ideal pistons and led to some undesirable inefficiencies. You can see the finished design. Pistons are actually the only thing you can't buy off the shelf in a hardware shop, so I'm going to be looking at making these more easily when I go back to Bristol. But I've got everything ready to install after a month of trying, and yeah, sky's open. Month of sunshine, day I'm ready, sky's open. Not supposed to rain for another month, but climate change and something, wet season comes early. But we're expecting some problems, so wait a couple of days, it's all good. But then when I was taking out the pump that was already in the borehole, which feeds the tank, which feeds the kitchens for the university, just turning off this tap, and the shoddy design or installation meant that it broke. So to replace that, but yeah, got it working finally. Rather temporary structure, as you can see, but the idea was just to test out the basic design, demonstrate it, and prove that it worked. The basic design consists of those plastic discs I showed you earlier, spaced evenly along a continuous loop of rope, and the plastic discs fit just inside a pipe that runs from the water at the bottom of the borehole up to the surface, and therefore, because they fit just inside, they bring water up with them as they pass up the pipe. It's a larger diameter pipe at the top, stop water spilling out the top, and a side arm attached to that to deliver the water. A loop of ropes driven by the pulley, which in turn is driven by the black motor there, which in turn is connected to those two 40-watt panels. That's the guide that's at the bottom of the well to turn the rope and guide it back into the vertical section, all 15 meters of the pipe, and brings the water up to the surface, and that's it back in the borehole. The larger diameter pipe there, you can see, is just to guide the rope back into the borehole, and the rope's actually free all the way down to the guide. So as I mentioned, the two 40-watt panels, the 80-watt sort of solar panels are used. They cost about $500 US. The motor, I'm hoping I can get one that will have the same specification from a car windscreen wiper motor. That should cost around $150 US, and the pump itself will only cost $100 US. So that's $750 US in total, delivering 3,000 litres a day if run for 6 hours, which it was managing to do while I was testing it out. Also managed to demonstrate it to the students at the Sustainable Energy Department at Mzuzu University, where I'd installed the pump, and they'd agreed to take it on next September as their final year project, and a lot of interest. And I'm now actually back in Bristol doing more lab tests on the system, so I can fully specify it up for the Malawian students and give them full engineering drawings of the basic system, which they can fully test out and think of any improvements, and then it should be ready for manufacture and installation and use by April 2010, hopefully, but don't hold me to it. Anyway, till next time, part.